Okay, testing. Make sure. Okay, seems like we're on. And then let me check my audio. Okay, audio looks like it works. Okay, I'm just gonna connect my device. Awesome. Okay. So yesterday we did negation. And today we're gonna start a new lesson, subtraction. So this should be pretty easy to tackle. So let's get started. Okay. So 1.5 subtraction. Okay, so what do we mean by subtraction, such as 9 minus 2? Of course, you know that 9 minus 2 equals 7, but in order to generalize subtraction to work for more complicated numbers, such as negatives or fraction, it will be useful to define subtraction as a combination of addition and negation. This also has the bonus of letting us use rules and properties that we've already established in the chapter for addition and negation. So I think what they mean so far is that with 9 minus 2, we can really say that this is 9 plus the negation of 2. And using the property of negation x plus x, which gives us 0, we can use that property to help us out a bit. So if we take 9 or 7 plus 2 plus the negation of 2, we see that if we use an associative property, that we can actually cancel out the 2 because we have its additive inverse. So we know that that gives us 0, so 7 plus 0 is obviously 7. So I think this is what this chapter is mainly going to focus on. Generalizing subtraction and addition. So as a substitute for subtraction. I'll move this example here. Okay. Yep, and the next page even states the definition. A minus b is really a plus the negation of b. Subtracting number means adding its opposite. Yeah, we saw that here. Adding its opposite. Because the negation of 2, the opposite of negation 2 is 2. Our goal is to explain how subtraction works with 0 and with negative numbers, and to explain some of the other properties of subtraction. Negation and subtraction look the same, but are different operations. Negation takes one number and return its opposite. Subtraction takes two numbers and return their difference. Even though negation and subtraction use the same symbol, you should distinguish in your mind between negation and subtraction. Okay. And here comes the problems. So problem 1. So what is 0 minus 17? Well, using a property that they want us to use, well, we know that because of the addition property of 0 plus x, which gives us x, we know that this will just be the negation 17. B, 17 minus 17, that's really that. And using the property that we've shown above, we know that this result will give us 0. Now, see 17 minus 0. Well, we know that the negation of 0 is just 0. So this is just a positive 17. Move on to the next problem. Problem 22. Use the definition of subtraction to explain the following equations. Okay. So we'll start with A. 11 minus the negation of 13 equals 11 plus 13. Okay, so I think we'll start with the left hand expression. So using the property, they said that, well, this is really plus the negation of the negation of 13. We know that a double negation is just a positive number. So that's how we get the result. And we could also do the same thing on the right hand. We could say that, well, 11 plus the double negation 13, and we'll get the same answer because 13 is also, or can be represented as a double negation. But I think it's much easier on the left hand side to show you what's going on. So B 13 So let's go on the left hand expression. So we have negation 11 minus 13, so we can rewrite this as negation 11 plus the negation of 13. And then we have this interesting property where we can actually take negative 1 times 11 plus negative 1 times 13. And then we can actually factor our expression now because we see a common factor, which is the negative 1. And then add our 11 and 13. Voila, we now come with the same expression that was on the right hand side. Now we can also do this on the right hand side by distributing or handing out the -1, because this is really a -1 right there. And we'll get the same expression as the left hand side. Okay, C. So 11 minus 13 equals 13 plus 11. Okay, so I guess we'll start with the left hand side. Plus the negation of 13. We know that, let's see here. I think I might have to go back a few pages, and no, that's multiplication. This is pretty weird because I see on the right hand expression that we can distribute the -1. But somehow the 11 doesn't become negative. So that's really weird. So let's try this one. So we know that's 13 minus 11. 13 plus 11. Oh wait, okay. I think I wrote this wrong. It's actually like that. Okay, so that makes things a lot simpler, because I was like, this doesn't make any sense. So, okay, this changes things. Make sure I've got this. So I think it'll be simpler to start on the right hand side. And we'll do both just to see. But we distribute that -1, we get -13 plus, we can even say we get that, which gives us 11. You know, that's just negation, so we can actually move the numbers around. So we get that. And then for this one, let's see. So we have 11 plus the negation of 13. I know that if we do the double negation of 11, let's move this bit, plus the negation of this, then we can get a common factor, I believe, because then this turns into this, and this turns into this. Okay, I think we're onto something. Now we have a common factor, so this becomes negative, and then we could just do 13 plus the negation of 11, that then turns into 11. So the left-hand side is a little bit more trickier. I think you just have to realize that 11 is the same thing as a double negation. And then it just makes sense. Like how they got this answer. Okay, problem 23. Find numbers a and b such that a minus b is not equal to b minus a. So we're trying to show numbers where a and b is a minus b is not the same as b minus a. So I think they're trying to show that subtraction is not commutative. So I think any number would work really. So 3, 2. Because this would be 1, 2 minus 3, that would be -1. So yeah, any number, well, not every number, because 0 and 0. But some numbers will show that, yeah, subtraction is not commutative. Find numbers such that a, b, and c is not, or find numbers a, b, and c such that a minus b grouped minus c is not equal to a minus grouped b minus c. Okay, so they want us to show that subtraction is not commutative. I'll just do 1, 2, 3 and see what happens. So that's -1. So -1 minus 3, so it'll be -4. And then this is -1, 1. So 1 minus -1. So, oh shoot, I'm blanking. Hold on. 2 minus 3. Yeah, that's -1. And a minus. So it's really a 1 plus 1, which is 2. Okay. So yeah, that's not the same. So subtraction is not associative. Okay, what is the value of so using that property they showed us, we can do this. Plus 4 plus 3. And because addition is commutative, we can actually move the numbers around. So let's move 1643 together with the negation of it, so we can get 0. And then let's leave the 1994 alone. We know that the negation property with its additive inverse gives us 0. And then we know that this will be a negative number. Okay. So problem 26. What is the value of 268 plus? Okay, that's a lot of numbers, but we can do this. Eight. 1, 2, 7, 5, 6, 0, 7, 9. Okay. So I definitely see a pattern where we can turn these numbers right here into this negation form, but I don't want to do that. That's a lot of work. But instead we can actually group this number with this number, this number with this number, this number with this number, and get 100. So let's do that. This is actually kind of weird though, because we just showed that subtraction isn't commutative, but we're kind of moving the numbers around. Obviously, it's because we're turning this subtraction to a negation, and that is commutative because we then put a plus sign. But it's just something to think about. Like, even though I'm not, transforming the numbers, this is really this. This gives us the ability to move the numbers around. Now we can just do 100 plus 100 plus 100, just 300. Okay, problem 27. Okay, explain why this number, this expression times 64 is the same as this. Okay, so when we look at this expression, what I see immediately is that using the property that the book showed us, this -4 or this minus is really a negation. Now we can use the distributive property of addition over multiplication, which turns this into this. Now we can then transform this expression back into a subtraction. That's why that works. And then compute the following. I'm just going to take my work above and paste it here. And then we immediately realize that, well, this is just a negation. We can expand this to get 24 plus 2, but we already know the answer, so we'll just do that. And this is 128. Okay, so now let's move on to the last problem in this section. 28. Use the fact that 999 equals 1000 minus 1 to evaluate 999 times 345. Okay, so they want us to evaluate this expression right here. And they also give us a hint saying that, well, 999 is really 1000 minus 1. We can now distribute that 345. So we're left with this. We can now turn this multiplication as just this with 3 zeros, and then it's just subtraction after that. And then we have to subtract this somehow. $344. Seven, 6, 5. I gotta do this real quick. I'm not too sure. 10, 11, so no. Okay, hold on. I wonder if I could do this. Like, what is minus 1? That should be this, right? And then this makes the subtraction a lot easier. Okay, I think I can solve this the easy way. So we can take 345 and then we'll do this. Because that makes sense. And then put a little dot right there. We can then turn this into that, so we're left with this plus that. We now know that. So this 9 minus 344, which is 344 6 5. Is that even right? Oh my god. Okay, that is right. I had to pull up the calculator for that one. I was not sure. But yeah, okay, that's right. So now we can review our answers. So let's go back to problem 1, or 1.21. Okay, subtraction is defined as a negation. Yeah, it seems like the work they showed is the same thing. Yeah, we turn that 0 or that subtraction into a negation to get to negative 17. Okay, so they say that this is a definition of subtraction. So definition of subtraction is right here. Okay, so definition of subtraction is really x plus y. That's the definition. Okay, I'll remember that. B is solved in a similar way. Take the definition of subtraction. We see that we're just doing additive inverse, so we get 0. And then C is done a similar way. We know that the negation of 0 is still 0, so it means you're just adding 17 to 0, which means you just get back your same result. So it's really just definitions that you're doing in algebra. You're just messing with definitions. Like this 17 minus 0, well, that's really just double negation of 0. Now you can say, oh well, double negation of 0 plus negation of 0. Well, that's really just plus 0. So I'll get back the negation of 17. Oh, that's really just a positive 17. It kind of just devolves into the result, and we get our answer. Okay, so problem 22. Okay. Yep, it did the same thing as me. Cool. Where they take 11 minus the negation 13. We then use a definite subtraction to turn this into this. And then we know that double negation just gives us a positive result. So now we turn this into this. Okay. Yeah, we did that the same way. Which is a good sign that my thought process is the same as the person who wrote these problems. Okay, in a similar way, so we're at question B now. Minus 11, minus 13, so we take the definite subtraction again. As we can see, this turns into negation 11 plus negation of 13. And they did it a different way because they basically just skipped a step. That's all they did. Because in the previous pages, we already established that when we have this number, this actually means this. So we don't have to show that step again. They should already understand. Which, to a certain extent, I understand. Maybe I should just already know that I'll get a negative number. I gotta think about this now. How did they do that? So, took the definition of subtraction. I got this result. I then say that, okay. Yeah, on page 24, they already have an example where both operands are the negation, that we can actually turn this into this. Okay, so that's how they got it. They're using the definition negation of sum to skip over the distributive property, because we already established that this is how we can get the negation of sum, by using distributive property. I think I like my process better because I show the steps of how I got there, like why it makes sense to me, because I'm taking apart the numbers, I'm factoring in, or I'm expanding it and then factoring the numbers to get my result. But I digress. Let's move on to the next problem, C. So this part takes more steps. Okay. Which side did they do? They did the right-hand side. I did the left-hand side? Yeah. Similar process. Yeah, I think we can move on. Same process, so that's good. Okay, problem 23. Find numbers a and b such that a minus b is not equal to b minus a. They used the same numbers as me, I think, right? No, they used 1 and 2. I used 3 and 2. But we still got the same result, 1 and negative 1. So they're showing that subtraction is not commutative. So now associative. Find numbers a and b and c such that a minus b minus c is not equal to a minus b minus c. They used a as 3, b as 2, and c as 1. I did it the same way, but just in the opposite way, and I got negative 4 and 2. So subtraction is not associative. They even have a warning. Subtraction is neither commutative nor associative. Cool. And they also say that there is good news though. Remember that we defined subtraction in terms of addition and negation. And addition is commutative and associative, so we can use the following strategy for dealing with subtraction. To solve subtraction problems, change all subtractions to addition. Rearrange the additions using a commutative and associative property. Change some additions back to subtraction. Okay. So problem 25. And then we have 3 more after this. Let's see this subtraction to addition strategy at work. So let's see if I follow the same process. So I take the definition of subtraction for 1994 and 1643, turn those into a negation, then I add the addition back in, I then group the 1643 to get 0, and then we get a return, or I guess we don't turn 1994 back into subtraction, we just leave it there because we're using the definition to say that, well, this is just a negative number. In the book, they show a similar process, so I think we did a good job. Okay, next problem. Okay, they group all the numbers to get 100, which is what I did. And then they add all the hundreds and the answer is 300. Cool, I got the same result. No problem. 27. Okay. So now I think we're going to see an example of them using distributive property. So let's convert the difference to a sum and then distribute the 64. Okay, cool. So we're on the same page. We just distribute the 64, and then we can turn back the... We can optionally turn the 24 back into a subtraction problem, but I think we spoke about that. We can just do that in our head and still get 2, positive 2. And we're just left with 2 times 64, which is 128. So we got that problem right. So they give us a definition: multiplication distributes over subtraction. So we added something to our toolbox now. So we can do something like this, and we get this. And this goes to n terms, so B, C, D, F, G, whatever. And then we can get A, C, A, D, A, F, A, G. It's a surprising use of distributive property. We also got this problem, right? Problem 28. Okay. As prompted by the problem, we can write 999, that's 1000 minus 1. Okay, so we were on the same page until I couldn't figure out how to subtract this big number with this. So the book just does it in their head. I had to break this number apart, subtract the 1 first, and then we get 999, and then make it easier to subtract. So we still got the same answer. And that concludes all the problems. So now we can finally move on to the exercises. Okay, so exercise 1. What is the value of 85, then parentheses 33 times 22, closing parentheses, minus 33, open parentheses, times 85. Well, this is just 0. Because if we take the definition of subtraction, turns that into a plus. This is just 0. Okay, 2. Compute. I can already solve this problem in my head because it's pretty easy once you see it. Well, I already noticed that the right hand expression, this right here, is a 0. Anything multiplied by 0 is 0. So problem 3. Okay, the city of Alexandria had a temperature or high temperature of 18 and a low temperature of -5 on the same day. By how many degrees did the high temperature exceed the low temperature? So we had a high of positive 18 and a low of -5. By how many degrees? So what did it take for us to go from -5 to positive 18? So if we see this on a number line, we start from 0 and end up at 18. 18. And then I think the answer is really just this. So it took us 23 degrees. Okay, evaluate 3 plus. So this is a definition of subtraction, then double negation. So let's first convert all of these. We'll leave this alone, but then this. Wait, is that right? Is that right? Is that? Yeah, that's right. We can now group this, but we can also just subtract it. So this would be 6 plus 5 -1. Why do I feel like I did this wrong? No, I don't think I did. Okay. Problem 5. I think I did it right. Because if we do this first, 3 minus 9, that is -6. This is a double negation, so that's positive. Yeah, that's right. And just to double check, we'll do this. 3 plus 9 minus 5. Yeah. I use my calculator just to double check. So if x and y are numbers such that y minus x equals 7, what is the value of x minus 7? So y minus x equals 7. So if this was 8 and this was 1, we will get 7. But if we swap them, we'll get -9, I believe. I don't know, it's kind of weird because couldn't we also just do 6 or 10 minus 3? That's 7. But then we swap them. Hold on, that is a positive 1. So we get -7. I'm assuming that we'll get the same thing here as well. -7. So the value is just saying -7. Next problem is a long list of numbers that I don't feel like writing down. So I'm going to see if I could just do it in my head. 100 minus 2 plus... no way, I cannot do that in my head. Guess I gotta write it down. Two, 6, 3, 8, 4 minus 10. So we turn these all into addition. Get 200, 300, 400, 500. We get 6, 12, 20, and 30. Well, -30. See. Okay, I guess I just gotta do this the long way. We have 100 plus 101 plus 102 plus 103 plus 104. And then plus, skip over that for now. This is 3, 6, 10, 510 plus 2, 4, 6, 8, 10. I think we already established that this was -30. So this is 80. Okay. 7. Oh boy. This is a big number too. They are not playing around. They're not playing around. Okay, okay. So I know that negation or subtraction distributes over all of these numbers right here. So those are all negative. But then it's, okay, what's the result here? And how many numbers are here? So you know, 1 minus 1 plus 202 minus 102 plus 1903 minus 103 plus dot 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 plus 1993 minus 193, and then we're left with 100 for all of them. That's what we're left with. Okay. Times what? What, 93 numbers? 92 numbers? How many numbers are actually here? Okay, so we do get rid of all these numbers here. Get rid of all of those. And then they become part of this. So I think there's 92 numbers. Is there 93 or 92? I think there's 92, but if there's 92, should we divide the 92 in half? Get 46. No, that doesn't. Is there really 40? No, it can't be. Because this has 92 numbers and this has 92 numbers, which makes it a total of 90. Well, we're assuming that's 92 numbers. I'm not sure. But 92 times 2. And then divide that by 2 to get back 92. 93. Oof, this might be a problem that I will get wrong because I don't understand. Okay, let's skip over this problem right now. Actually, no. We're gonna try to solve this. I just don't know. I'm gonna take a guess. Let's say this is 92. There's 92 numbers in this list. And then, what can we do with that? Guess we could say 100 minus 8. This turns into that. And then this turns into another big number. Zero, 8. So we subtract that. Oh crap, I forgot how to borrow. Oof. Stat? Hold on. Wait. I totally forgot how to freaking borrow. We gotta use this calculator to double check this. We had 0, 0. This becomes this becomes a 9, this becomes a 10. That's 6, and that's 5, 7, 1. No. What in the world? So where do we borrow from here so we can get number here? So this becomes a 6. Guess that's our final answer. But this is a reminder that I forgot how borrowing works in subtraction. Review. I think that's wrong, but I don't really know. I think it's 92 numbers in there. But yeah, let's move on. Okay. By how much does the sum 19, 28, 37, 46, 55, 64, 73, 82 plus 91 exceed the sum? Same amount of numbers, just everything's increased or decreased by 1. So I can okay. This problem is easy. The other problem was not. What in the world? But exceed the sum. So this is a subtraction problem. Sure, we could add up all these numbers, but we can also do this. 19 minus 18 plus 28 minus 27. So we just need to add up how many numbers? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. Like if I were to do all that work, screw it, we'll just do it. Minus 54 plus 64 minus 63 plus 73 minus 72 plus 82 minus 81 plus 91 minus 90. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Exceeds the sum by 9. Okay. Compute this number. I see that we have a common factor, so we can do this. Because subtraction is, you can distribute it. This becomes 2. So we're left with oh, now we gotta do this. 2000 minus 10. I'm just gonna spam this technique. Becomes 4000 minus 20, which is 390 or 3980. Let's double check that. Yeah, I think that's right. Yeah. Okay, the last problem. The sum of the first 10,000 positive integers is how much more than the sum of the first 10,000 positive odd numbers? So what in the world? Oh boy. So I have to take the sum, or get the sum of 2 plus 4 plus 6 plus 8 plus 10 plus 10,000, and then this is all the even numbers and odd numbers. 1 plus 3 plus 5 plus 7 plus 9 plus dot 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 plus, would it be this, or no? Because it could be that, or it could be that. Okay. So we're taking E minus O, which means that we can distribute that negative to all of these numbers and then get t, or 2 minus 1, 4 minus 3, 6 minus 5, 8 minus 7. So that gives us all ones. Don't know if that's... I think that makes sense. Or does it? Oh boy, I don't even know. Because this is just 1 plus... just 1 times, or no. 1 plus... how much would that be? If there's 10,000 numbers total, we combine the two. Would it be 10,000 numbers? Or would it be 20,000? Because right now there's 20,000 numbers total. And I'm not too sure if this odd number ends at 9,999 or 10,001. And I don't know how to double check that without counting all the numbers. I think, okay, it's 2, 4, 6, 8, 10. How much? That's 1, 2, 3, 4, 5. That's 5 numbers right there. What does that tell me? And 12, 14, 16, 18, 20, 6, 7, 8, 9, 10. So that is 10 numbers. This is a tricky one. Numbers here. Okay, there's 5 numbers here. We're already at 10. What the heck? Like, would this be 2? This is that? How do you check that? Well, I guess that, okay. We'll just assume, well, okay, what if we know that this is 5 numbers right here. 2, 3, 4, 5. Yeah, we don't even need to check that. There's 5 numbers here. Okay. 2, 4, 6, 8, 10. What if we did this? We took a 2. Well, this is 1, 2, 3, 4, 5. Oh, okay. That's stupid shit. If we, this is really 5,000. So the next number, this would have to be at 20,000. That is 10,000 right there. Which means that this is at, well, because these numbers exceed, the even numbers exceed the odd numbers by 1, I think this would have to be something like this. Because we don't want a -1. So now there is 4,000 numbers total. We grouped that up, so we divided by 2. So now we're left with 20,000. So I think there's 20,000 numbers, or the even numbers exceed by 20,000. Oof, I have no idea, but let's just check. Let's check our answers now. So what is it? What section is this? This is section 1.5. Okay. So question 1 is 0. Question 2 is 0. Get those both right. We got this one right. 4 is -1. We get that one right. -7. We get that one right. 6. 480. We get that one right. 7 is, ooh, we got that one wrong. And there's really 93 numbers. So we came close. We just didn't know. We thought it was 92, but we had to count one more up. So it's 93 numbers. So this one's right. Number 9. This one's right. Okay, and then 10. Wait. Hold on. 398. Wait, is there more problems? Oh, we totally skipped over some. Crap. This is 11. We gotta do 10. 10, so compute 998 times 23 in your head. Okay. And, okay, so we gotta do this in our head. So if we take, what is it, 998, so that'll be 1,000 minus 2, so that'll be 23,000 minus 46. So that's what, 23,000 minus 46. So 22,900 and 22,900 and if we just use that technique again with the -1, it'll be 22,999 minus 45. It'll be 22,909 5 4. Okay, that's our answer, and then let's check this one. Yes, we got it right, baby. We did that in our head. And then 11. Wrong. We got that one wrong. It's off. So it wasn't. No. Crap. Ah, man. Of course. This is stupid. There is 20,000 numbers here. We grouped them up into 2, which gives us 10,000 numbers total. So the answer is really 10,000. That was an honest mistake. We were so close. But that is the end of the exercises and the end of this stream. We did all the problems in 1 hour and 23 minutes. That was a tough one. But it was a lot of fun. Okay, so Merry Christmas Eve to everyone. Hope you guys had fun watching a live stream. Okay, that was it. Bye, everyone.